Hi everyone, this is Pawan Kumar T from Mechanical Branch of First Year from VIT Vellore. Today we are going to discuss about laser principles and its applications. These are the topics we are going to discuss in this lecture. Properties of laser means uh, absorption, one is emission, stimulated emission, and optical pump, optical pumping, and population inversion, light amplification of laser, and the characteristics of laser. Initially, what is meant by laser? Laser means not only a single word, it is the group of words formed together. Laser means light amplification is taken by stimulated emission of radiation. It means amplification of light is taken by the process of stimulated emission by which we can achieve the laser. When the man discovered the fire, the darkness is vanished. Till the man used only the natural source of light. When the centuries are passing, the various forms of lights are being came up, like lamps to the fluorescent bulbs. Laser is using everywhere in our day-to-day life, from a barcode scanner in any shops, shopping malls, to the highly detected area, like like any shopping malls or golden malls and etc. From laser pointer to the printers, from removal of tattoo to the high complicated eye surgeries. Laser is using everywhere because of its nature and behavior. Scientists struggled a lot to discover a narrow beam of high intensity powerful light. These are the theory of from the theory of light, the laser principles are came up in 1916. Uh, Later, it is developed by the Gould in 1957. The first working laser of optical laser is ruby laser. It is discovered by the Neumann in 1960. It is the first working laser. Laser medium. Laser medium means in which the medium in which the lasing action takes place means the process of lasing action takes place called laser medium. The medium may be solid, liquid, or gas. Xenon and helium are the examples of the gaseous lasers, and this semiconductor is a solid laser. We can discuss about working and principle. Principles of laser are absorption, spontaneous emission, stimulated emission, population inversion. Initially, absorption. What is absorption? Atom contains many energy levels. Let us consider two energy level, Ex, E naught, and the E naught, E naught, and Ex. Sorry, X. When we pass some amount of energy in the form of photon, the electrons absorb that energy and goes to the higher levels to and means this process called excitation, uh, and this process is called absorption. Spontaneous emission. Spontaneous emission means when the electrons absorb energy and goes to the higher levels, it will not stay for longer time in the higher levels due to the tendency of electron to stay in its ground state. This come back to its ground state by the emission of photon. These these are emission of photons in the form of a radiation of light. These lights are incoherent. As the atoms are excited to the higher energy states, it will not stay for longer time. Approximately only they will stay for 10 power of minus 8 seconds. If it stays more than 10 power of 8 seconds, means 10 power of 5 seconds, then that is called metastable state. Stimulated emission. When the electrons go to the excited state by absorbing energy, and when we pass some amount of energy, due to the disturbances, the electrons come to the ground state by the emission of photons with additional to the given photon. These these lights are highly coherent. So the stimulated emission is process is used in the laser population inversion. As the electrons go to the excited state and comes to the ground state again. But for lasing action to take place, the number of electrons in the ground state should be greater than the number of electrons in the excited state. This can be achieved by optical pumping. This occurrence is known as population inversion. Optical pumping. This can be achieved only by optical pumping, and this occurrence is known as population inversion. Working of laser means when the electrons absorb energy, it goes to the higher states as we discussed earlier, and these electrons goes to excited state by absorbing energy and come back to the ground state by the emission of photon. But some of them will be stayed back in the excited state for longer time, and these are caused for the laser. This medium is known as active medium or system. Active medium or system. Active medium consists of different types of elements or compounds. Let us consider a large number of electrons or elements in a thermal equilibrium state at a certain temperature T. Let the N naught be the number of electrons in the lower energy state E naught, and the Nx be the number of electrons in the excited state Ex. According to the Ludwig-Boltzmann, Nx equals to N naught into e power minus of hv by kt, where k is the Boltzmann constant. As we know that energy of Ex is greater than E naught. According to the Boltzmann equation, the number of electrons will be in an excited state less than the number of electrons in the ground state. But this process will not is suitable for the laser. So only by thermal agitation process, the number of electrons will be higher in the excited state than the lower energy states. As we goes on increasing the temperature, the number of electrons will be increasing in the excited state. Again, we can discuss about laser, how the laser works. As we pass some energy to the electrons, these electrons will go to the higher energy states. All electrons will go to the higher state by optical pumping, and population inversion takes place. Population inversion takes place, and this all electrons come back to the ground state by the emission of a highly coherent beam of electrons. So by this way the laser works. Einstein, according to Einstein, The equal probability of absorption of electrons equal to the probability of electrons in stimulated emission. Thus, by the stimulated emission, the more number of photons will be evolved compared to the absorption. So the lasing action, the laser works in the by the process of stimulated emission. The main important characteristics of laser are monochromaticity, coherence, directionality, intensity. Monochromatic. Lasers are highly monochromatic in nature because they will have a single color or a wavelength. But in our daily using fluorescent bulbs, it is the combination of several wavelengths or lights emitting. Coming to the coherence, laser is a highly coherent. As we see, they will be phased in space and time. The crust and states are same, and the nature is going to be same in the laser. But in normal light, they will be in different form, incoherent. They will be different wavelengths. Laser is highly directionality. They can go to the longest several meters into the sky, whereas the normal light, whereas sorry, whereas the normal light only goes to the some few meters into the sky by forming a large beam of light. Narrow beam in a specific direction without any dispersion, whereas in normal lights it will be more dispersion like this manner by applying a large spear-like structure compared to the laser. Laser will be a very small narrow beam of light till the end. It is highly focused and high intensity light compared to the, as we know that in ordinary lamps, the spot and the middle of in the middle it will be dark and it will be reduced slow as going to the ends of the sphere of a light. But here it is with whole thing will be in a similar way. This is due to the high intensity. Laser is used everywhere in our world, and in a day-to-day life we can see in many applications the laser has been used. Now let us take the 2-level, 3-level and 4-level systems, how they work and how a population inversion takes place. In two-level system, it is very difficult to achieve the population inversion. It requires high optical pumping, high energy to excite the electrons to the high energy states E2. Let us go to the 3-level system, E1, E2, E3. As the electrons gain some energy or through optical pumping goes to the higher energy states and immediately return back to the E2 system by non-radiative transition. It emits less amount of heat, and thus E2 is known as metastable state, from which the electrons transfers to the ground state by the emission of larger radiation and compared to the E3 to the E2 level. Approximately some example of 3-level system is a helium neon laser. ruby laser, etc. So example is ruby laser. Now goes to the 4 level system. The electrons goes to the higher energy states by optical pumping, and it will go to the E3 state by the non-radiative transition, where the less amount of heat is liberated, as we discussed in the 3 level system. Uh, from E3 to E2, it is the important transition through which the laser light is produced. Here, from E3 to E2, more amount of radiation will be produced as compared to the E4 to E3. And again, from E2 to E1, and there will be, it is also non-radiative transition. As we discussed, the population inversion cannot take place in the 2-level system. The 3-level system must be pumped harder than the 4-level system. That is due to the more number of molecules present in the excited state. I hope you all understand about, I think you can have a little bit idea about laser, how it works.